Hello, this is Greg Allison from Galactic Greg's, coming to you from an undisclosed location somewhere in the Milky Way galaxy. And I'm going to talk to you now about air recovery of objects from space, for especially small reentry vehicles, with special emphasis on the recent announcement by Rocket Labs of air recovery of their Electron rocket. But there's some other projects that you never heard of that were intended to be air recovered also, including one that I worked on at NASA as a contractor. Of course, I'm not a NASA person. I'm not a spokesperson for NASA. In no way do I speak for or represent NASA. I represent Greg Allison from Galactic Greg's. That said, I have worked as a contractor on a project called HyTEx, and I will talk about that because we intended to air recover from that. And I will mention a couple of other crazy projects that we're looking at air recovery, such as the Saturn V SI-C stage. And I will talk a little bit more about that, but not much. And I will also mention the Genesis probe, which went out to collect comet dust, and it was intended in air recovery, except it went smash. But we'll briefly talk that. In the meantime, I would like to say, before we get into that, if you've not subscribed to my channel, please do subscribe to my channel and bang the update notification bell, because I'm going to get up and start doing a lot more videos here on various space topics and other science topics also. And I do have some links below you can support my channel with. They are associated with my sister channel, Green Greg's. If you're interested in gardening and prepping, go check that channel out. Now, that said, I want to get into this presentation, so I'm going to share a PowerPoint file that don't have words in it, it's just mainly pictures. And so we're going to kind of get into this, and let me explode this thing out. Oops, and make it bigger. It's kind of hard to do on the screen because the other things that keep popping in place here. And then we're going to go into view here. There we go. As I mentioned, there are three projects, well, two principal projects I'm going to talk about, being this project here, which is Rocket Lab's project. And Rocket Lab is a small launcher that has made an amazing announcement, a very bold announcement, I might say, for the air recovery of an orbital launch vehicle that's small, which is no small feat at all. That's what I'm covering. It's very exciting. And this HyTEx project here, which I worked on. Now let's kind of flip into the pages here. Greg, why do you care about, why do you want to talk about small launchers when we got the huge Starship from SpaceX, when we got God knows what kind of projects that Blue Origin's going to come up with? We know about New Glenn. Do they have a new Armstrong? What's under the books? Well, of course, they got to fly something to orbit for new Blue Origin. And you work on SLS, right, Greg? Why are you talking about small launchers? Because small launchers are exciting, because even SpaceX started with a medium size, and for a low orbital launch, it's fairly small launcher with the Falcon 1, and rapidly spun up in size. And you will discover there's quite a payload niche for small launchers for dedicated to the spot they want to launch in launches. That's hard to get, and they're willing to pay a good price for that. And those companies can expand and become bigger companies down the road, but they've got to get started somewhere. And hopefully they'll keep servicing the small launchers. As I mentioned, I myself have quite a history with small launchers. Greg, that's just an amateur rocket. Actually, this rocket's all motor from here back with a graphite nozzle. That's a hybrid rocket with a nitrogen oxide oxidizer tank right here. The oxidizer tank is actually formed from two fire extinguisher tanks butted end to end. This was our HAL 5 Halo, HAL 5, L5 Society, altitude liftoff, ground launch 1 rocket. This is proof that, yes, I was, at least at once in my life, outstanding in my field. And this is the launch of that rocket. Now, this was our Sky Launch 1 rocket that we launched from a balloon. And here I am here. And I'm trying to make room for everybody else to squeeze in the picture. Well, I wish old Steve had done that for Gene Hornbuckle, but I meant, yeah, not Gene Hornbuckle. This is Gene Hornbuckle over here. Gene Young, excuse me. So that's Gene Hornbuckle, Tim Pickens, me, Steve Mustakas, Gene Young, Peter, oh shoot, I'm forgetting his name. Anyway, let's move on. This is our ground launch 1 rocket here, being launched from Topsail Beach, North Carolina. I'll just go through these briefly. And that's the rocket underneath. It made the Guinness Book of World Records, by the way. And this is our ground launch, Sky Launch 2 rocket, which we actually launched from NASA for a river barge. And that one didn't turn out so well for us. Another story, I won't go into all this, but this rocket's hanging in the Straightdale Brewery in Huntsville, Alabama. This is the High Altitude Research Corporation, activity we spun off from the Huntsville, Alabama's HALO project. And that little short red tuft of hair right there is me with my hand up on the booster of the balloon launch return vehicle. That's a subscale ground launch of that. And this vehicle ascending into the air. This is a boat called the Mr. Calais, which is a utility boat. And this was our Cat's Prize rocket, cheap access to space prize rocket. This thing's 17.5 foot tall in a launch gondola off the deck of a utility boat known as the Mr. Offshore that used to operate for the Naval Coastal System Stations, Coastal System Stations out of Pensacola, Florida. And this is from a video when it was starting to be lifted by the balloon. And I believe this is probably Mike Smith cutting the launch cord there, or it might have been either Mike Smith or the late Glenn May. Glenn May got killed in the Spaceship 1 co-flow test, as you might, Spaceship 2 co-flow test, as you might know, 1 of 3 people. And this is it on ascent, the Hart Cat's Prize rocket. And here is the balloon just before the rocket launch, and when the rocket launches, all the plastic for the gondola greenhouse is stripped off. And this thing didn't go as we'd planned either in this case. I'll talk more about these in future videos. And so we'll go a little bit into some other launches that we're talking about air recovery, because that is our main topic here, is air recovery. I'm just showing you that I had a history with small launchers, and I find them very interesting as such. And we will talk more about those in future videos. More reason, if you're inclined to want to watch that kind of stuff, to click subscribe and update notifications, along with the bigger stuff like Starship and New Glenn, whatever else that Blue Origin comes out with, SLS or whatever, whoever else, including, I think the Indians and the Chinese have some interesting programs that we need to keep an eye on. Indians are super excited about space. Those guys, they get me excited with the stuff they're doing. And several other countries are involved in space. Anyway, you may have heard of the Genesis sample return. Genesis was intended to snag the parachute directly on return of the capsule that went out to collect particles of solar wind. And they did quite a few practice runs with this thing to check out the capture. And that part was working right, but unfortunately the drogue chute circuitry wasn't set right and the parachute failed. The drogue chute did not deploy and it smashed into the ground. Believe it or not, they still recovered samples from it. Most of them were contaminated, but some of them were still good. Imagine that. That's pretty amazing. And then there's this. Oh my God, a helicopter recovery midair of a Saturn V SI-C first stage. Holy smoke! Yeah. I don't know about that, but anyway, this was somebody's idea and made an artist drawing. That might be fortunate they only got that far. But there was a more credible SI-C recovery concept called the F1 flyback, F1 for the engines, 5 F1 engines. See my video on the mighty moon rocket engine, the F1. And here they were looking at giving wings. See, everybody's aware that early in the space shuttle program, they were talking about having a manned flyback booster, but that was proving to be too expensive. So they tried to come up with an unmanned flyback based on the Saturn S1C first stage. They called it the F1 flyback, and it was a serious contender, but it's going to take $200 million more to develop that than the solid rocket boosters. And development money always wins out over sustaining money in programs when federal budgets are tied up front. You pay for it later. And of course, we know that probably was not too fortunate for the Challenger space shuttle. But all those problems with solid rocket boosters were worked out, and they're pretty solid today, I might say. Anyway, just a little history of other returnable methods. Now, what like I said, I'm most excited about is Rocket Lab. These guys are very innovative in that they've actually instituted printable, 3D printable rocket engines. Now, I'm one of the guys who would have said, what? Why would you want to do a 3D engine? Because, you know, the strength of the metal is associated with the length of the grain of the crystal in the metal. And when you're printing it, you don't have any crystal grain lengths. But somehow they're making these engines and they're working them, and SpaceX and others. And I got a friend in Huntsville's got Steve McKechnie got a company called Plasma Processes, and he was doing that before any of these guys. So you know, you could argue that till the cows come home, as we like to say in this neck of the woods. But 3D printed engines are in use, and they seem to be working. They've done a lot of testing, and it's surely a cheap way to build very complex engines without having to have all the little bitty piece parts we've had in the injector heads and things like that, and liquid motors. And I can go into that in future videos too. I'm going to do videos about rocket engines in more detail after doing some little brief introductory Rockets 101 simple thing to give you a little simple background. Anyway, Rocket Lab has been very excited because they are going to that market niche of providing a payload to a dedicated orbit. That's for a single payload. You want to go to this orbit this time, we can put you there. Because SpaceX is putting on a lot of pressure and say, hey, we're going to launch a zillion microsatellites, well, not a zillion, but just they come with a new microsatellite launch deployer, probably based on their Starlink, you know, system. But and that's a whole nother video. But their deployer suddenly offered really cheap rides for microsatellites, and so that put pressure on Rocket Lab. However, those orbits are to one place, one orbit. It's not dedicated orbits, which still is a special market niche, which has a good demand for it. But that said, it still puts pressure to bring the cost down. And so Rocket Lab took a hard look at that, and their CEO, Peter Beck, at a small satellite conference on 6th of August, made the announcement for how they were going to tackle that. And indeed, they chose to go the air recovery route. You see, I'm kind of circling here. This is the rocket, the Electron rocket. They call it Electron because they're actually using batteries to power the thrust vector control systems instead of hydrogen and so-called nasty propellants. Now, that's cool. I might have a bone to pick, though, with lithium-ion batteries from a safety and reliability standpoint when you use whole lots of cells in a rocket flight application. That's a subject for a safety video in the future, maybe not too far away, and maybe a lot of battery videos too, because that's one of my hot points. There it is, the Electron rocket. That's an amazing rocket, small rocket, and it's carbon fiber composite rocket, and it's only a 1.8 millimeter carbon fiber hull. Now, that's the challenge though on re-entry. So they're not doing a powered flight to bring this thing back in like SpaceX. Why? Because a little bit of extra fuel and those kind of systems would dramatically impact the overhead of a smaller vehicle. It's like tank size. If you increase the tank size of the rocket, the weight goes up, you know, according to the material you're putting on it, like by the square, because it's the surface area of the tank itself. Whereas the volume of fuel goes up by the cube. So bigger rockets get a lot of margin for adding extra fuel, which increases the mass fraction, the fraction of fuel to the weight of the rocket, and makes that a whole lot better performing stage. Smaller rockets have a lot of challenges where they can't really live with things like that too well. And so, how do you bring this rocket back and dissipate all the energy? Because this thing is gone to near Mach 8.5. That's what this first stage is going to, Mach 8.5. You know, orbit's actually 17 and a half times the speed of sound. So they're trying to bring this back from Mach 18.5 to 0.01 times the speed of sound in 70 seconds. 70 seconds. That's 3.5 gigajoules of energy to be dispersed in 70 seconds. In a single instant, that's enough energy to power 57,000 homes. And this, of course, is what Peter Beck was telling us. He told us all these things I'm going to tell you, maybe in different ways than I'm telling you, but pretty much the same information. And what happens is they get these temperatures, especially where you got these shock waves, get up where these shock waves exist around the vehicle. This is their aero modeling. You're at you're at a half times the temperature of the sun. That's hot. and you got huge aero load on this thing too. Oh yeah, now look here. In some cases, it actually touches the vehicle. Where it's actually touching on the vehicle, you would call that a plasma knife. That's the one hot plasma to cut through almost anything. To handle challenges like that, you have to have some really good TPS, thermal protection system, on this stage, and or other means to remove the heat. As we know, Starship from SpaceX is going to have kind of a leaky fuel to help take some of that heat away, which is a great idea. And let's hope it all works out. Now, to make it worse, the aero loads as this thing coming back through the atmosphere is equivalent to the weight of 3 elephants standing on this booster, which has a carbon fiber shell of only 1.8 millimeters. Oh, did I mention carbon fibers don't like heat? So it's at half the heat of the sun with 3 elephants standing on it. Can they accomplish this? Well, I don't know. I hope so. They're trying. They think they can do it. So let's hope for the best and hope they can pull this off, because the more players, the better for market forces and for our future. And so I'm really excited about what they're trying to do. This is a huge challenge. At first, they said they could never do it because they looked at this like hitting the wall. The whole idea of trying to bring a small booster back and reuse it. That's tough. The fact that they have chosen to take on this challenge is amazing. Absolutely amazing. And it takes a lot of guts, as we shall say. So my hat, in fact, it's Greg's hat is off, my Apollo commemorative hat, to Peter Beck for that. But we're going to talk about other projects here. We're not just going to focus on his. But I do want to say that he's got to use a combination of thermal protection systems and aero deacceleration techniques to get that energy off this first stage booster coming back. And it's bringing back his engines, as you can see. So I'm amazed. I'm enthused. I'm excited because the challenges they're facing to do this for a small company, it's tough for a small company to do big things because, you know, how many extra people can you hire in? And they're a small operation. They got to be cost competitive. And yet they're doing things like this. This is an exciting time in space. This is their capture. Here's their helicopter. This is the parafoil. This is their booster and the drogue chute. And so they got a mechanism hanging from the helicopter off of a winch. And I have worked those winches from the helicopter before on another program I worked. And they're going to catch this thing and haul it up. How about that? And so I'll tell you about it. Oh, I think I'm missing something here. Go back there. Oh, yeah, we talked this, guys. All right, so now to talk about HyTEx. This is a project that I worked on back from late 2003 to 2004. HyTEx was an experimental flying test bed. And you can see it showing the helicopter here and a parachute. Well, because they intended air recovery of this. This is a reentry vehicle, a maneuverable reentry vehicle that was to be provided to us by Sandia National Laboratories. This was developed to have a targetable, flyable, maneuverable ability to deliver a nuclear warhead. Now, whether they were trying to get it better on target or evade countermeasures or all the above, that's outside of my realm. We were just looking at this as a flight bed, test bed for testing thermal protection systems, avionics, and several other, we want to do some control avionics tests. We wanted to be able to fly this thing around upon re-entry. So it was a test bed project. And this simulates the profile of the launch, coming up, flying around, coming back down, and getting captured by a helicopter. And it was called HyTEx, as I mentioned. This is the re-entry vehicle. And Sandia National Laboratories was providing the re-entry vehicle, and to show some of the different things that we'd put in here as samples to test. The Department of Defense, of course, was involved in this. The Army was involved in it from the helicopters, or maybe it's the Air Force in that case. I guess it was the Air Force. But we were going to fly off Saturn rockets off Wallops Range and Maryland. And I went there, and it's a nice place. We visited Chicoteague Island. And, oh, you talk about something in the middle of nowhere. Hard to believe there's something that isolated in that part of the country. But this is a flight profile. And this shows it sitting on top of the sounding rocket with a shroud over it. And this shows Well, yeah, there was going to be some kind of mid-air refuel. The thing is, these helicopters going to have to be mid-air refuel to get to location, and we were going to have the recovery based somewhere near Bermuda. So we were going to take NASA's solid rocket booster recovery boats and take them out to Bermuda and fly in that direction and have these guys snag the reentry vehicle. It was going to deploy a drogue chute and a parachute, just like Rocket Lab, and hang down and get a mid-air retrieval. So that was what we were looking at. Very much just like the Rocket Lab. So the thing is, Rocket Lab's project is very innovative, very gutsy, very bold, and especially because they're doing this from orbit with a composite vehicle, a stage, not a re-entry vehicle, which is designed for the heat. And the same was true of the Genesis sample return. That was also pretty much a re-entry vehicle. It was just a capsule. So doing this with a booster stage, a small booster stage, is extremely challenging. So as would have been capturing S-1C Saturn V first stage with a helicopter in midair. Would you want to fly the helicopter? Here comes this huge booster flying down, tumbling around. You're going to go up there and grab it? I don't think I want to be in that mission, but anyway, somebody thought of it. I don't know how far that went, but maybe they thought they could use RCS or something to stabilize that thing and make it capturable. And I'm assuming they had some kind of techniques for doing that. But in any event, we are in a very exciting time in space. There are small companies, large companies doing exciting things. NASA will start to focus more and more on exploration in the future. And so the next 4 or 5 years is going to be off the charts exciting. So I will be doing tons of videos on all these different topics and some other science topics that are related, as I mentioned, like batteries. I might cover some safety stuff, and then I might even come up with some separate videos on Patreon or do some lessons, because it may be beyond the interest of you guys and what you want to see. Of course, you can leave messages below and talk to me about that. You know, in terms of what you actually want to see. I got a lot of video from test stand activities from the HALO program, a lot of our flights from HALO and HARC. I got a whole cabinet back here with shelves stacked up with videos on them that I could convert the digital. That's old VHS tape. If I don't wait too long before that tape rots, I can convert that and put a lot of this stuff on this channel. Or I might have a sub channel. Stuff might be too boring for you guys. But tell me what you want to see below. I got hours of stuff I could post, or I could cut snippets out and make little talks about it. I've got tons of PowerPoint presentations I can talk from. But in any event, that's what we have. A very exciting time for booster recovery, large and small now. So stay tuned. It's going to be a lot of fun. Thank you, everyone, for watching.